Okay, so adding and subtracting rational expressions. So we do something a little bit different today. We still factor denominators, right? So that's definite first step. Any rationals you do, it's always factor denominator and non-permissible values, right? Which we don't use anymore, so we use restrictions now, right? It's always going to be x is not equal to. So let's just start off by doing something we know how to do. So what if I had to add a half plus 2/3 plus 3/4? What would I do?
If the denominator is the same.
Yeah, we need to get a common denominator, right? So what's the common denominator for 2, 3, and 4? 12, right? Okay, so if I want to write 1/2, but I want to write it as something over 12, what does it become? 6 over 12, right? It would be 6/12. I want to write 2/3, but I want to write it over 12, what do I write? 8. So what's happening? How are you doing that? You get 2/3, and I want to put it over 12. Why are you doing an 8 here? Okay, you're multiplying by 4, right? So you're saying, well, I need to get a 12. It's got a 3, so I'm going to multiply it by 4. And I have to do the same top and bottom. And the 3/4, 9 over 12. Now you could then write that as 6 plus 8 plus 9 all over 12, right? Just keeping the common denominator and showing that I'm adding these guys now, right? Which is, whatever, 23 over 12. Okay? So that's pretty much how you would have done it in the past, right? Works very well. I'm going to show you just a little variation of that, right? And I'm going to say, okay, so here's what we did, right? We said the common denominator is 12, right? And then what we did was we converted each of these separately. So I'm going to say, let's try it this way. We're just going to say, you know what? The common denominator is 12. So I'm just going to write the 12 count 1. Didn't hurt.
There's a desk there.
Yeah. When the computer falls and whatever it's going to be. And I'm going to say, well, what did we do to the 1 to make it over 12? We had to multiply it by 6, right? What do we do to the 2? Times 4, right? So we're treating each of these separately. So we know the 12 is there, so I'm not going to write 12 each time. So the 2, we have to multiply by 4. What do we have to do to the 3? Multiply it by 3, right? So that's going to be equal to 6 plus 8 plus 9, all over 12, right? I'm not going to change anything there, right? Which is 23 over 12. Okay, now you probably wouldn't have done something like that in the past, but now you're going to start doing stuff like that, right? Because it's an easier way when we go to add rational expressions. Okay, and also it works fine for fractions too, right? Okay, so let's use this idea, and let's say we have 3x minus 1 over 6 minus 4x plus 7 over 2 plus 2x plus 3 over 3. Okay, so let that sink in for a moment, right? So first of all, we've got to factor stuff. There's nothing to factor here, right? Okay. Restrictions, are there any restrictions? No. Okay. So for there to be restriction, there has to be a variable in the denominator, right? It's got to be some way to make that denominator 0 if there's going to be a restriction. Okay. What's the common denominator? 6. Okay, so we figure out there are no restrictions. Write that over here. No restrictions. And the lowest common denominator is 6. Good. So we're going to put a 6 down there. So now, what I want to do is take each of these expressions and make it so it's over 6. So I've got an expression, 3x minus 1, right? And I'm going to make sure that I put parentheses around it, right? Because that's an expression. So how do I make it go over 6 based on what it was over? Yeah, really, I don't have to do anything to it, right? It's already over 6, so if we want, we could say, well, all right, fine, multiply that by 1. Minus, okay, next expression is 4x plus 7. Now, the 4x plus 7 is over a 2. What am I going to do to it to make it over a 6?
Multiply by 3.
Multiply by 3, right? Okay, so we're going to go times 3. Plus, right now I'm doing for the plus, just pulling that down, extend this a bit. The next expression is 2x plus 3. And what does it need? Multiply by 2, right? So I often ask, what does it need, right? It's like if we're going to write it over 6. So if you look at any one of these in isolation, I've got 3x minus 1 over 6. Okay, it matches up with that. If I cover up these two guys, if I've got the 4x plus 7, it was over 2, now it's over 6, so I'm going to multiply it by 3, right? Because that's what I'm doing here, right? Multiply this by 3, multiply this by 3. Okay, so now we can go through, simplify. Okay, so this is 3x minus 1. Now I want you to write the rest of the line. So all you're just going to do is go through and simplify it out, right? Multiply out by whatever, and watch that you get your signs correct. Right? Because if you're going to make a mistake, that's where it'll be. Okay, so I think that's the next line. Agree, disagree? Are all the signs correct? Okay, so the thing to watch out for here really is just when there's a negative sign, right? So you just say, okay, I got to multiply by 3. Oh, really negative 3, so it's minus 12x minus 21. All right, then we collect all the terms. So 3x minus 12x is negative 9x, so I've got negative 5x. I got minus 3 plus 6 is plus 3 over 6. I don't think I ever wrote the answers down. Oh, no, I messed up something there. Is that right? Oh, negative 21, right. So negative 1. All right. So negative 20, minus 16. There we go. That's better. So watch you don't miss anything. It's easy to miss things, right? So maybe what I want to do is this, sort of go like, okay, so I've dealt with the 3x, so that gives me negative 9x plus 5x, and then I've got minus 1, minus 22, minus 16. Okay, so there we go. Okay, and you can leave it in that form. Right? Questions? All right, let's ramp it up a little bit. Okay, sweet, it gets more fun. That's it. You know, we'll just have 2 terms, right? I mean, if we're going to up the increase what it is we're expected to do, we'll drop the number of terms down to a couple. What's first step? Factor. So in this case, denominators do factor, right? Okay, so you factor. All right, so the first step in adding or subtracting is factor the denominators. The second step is to put the restrictions. So what can't x be? 1 negative 1, right? So we're just going to write that as plus or minus 1. Okay, if we've got the same value, it can't be 1, it can't be negative 1. We'll say plus or minus 1. What's the lowest common denominator, right? Because I do want to add or subtract these, so what's the lowest common denominator? So let's do numbers first. Between 2 and 3, what's the lowest common denominator? 6. Okay, so I need a 6. What else do I need? What else do I need?
X minus 1.
Right. So for the common denominator, I'm looking and I'm saying, well, if there's numbers, I need the lowest common denominator of the numbers, right? The smallest number that both 2 and 3 go into. So that's 6. I need an x plus 1, and I need an x minus 1. Okay, so what do? Well, equals, big line, 6. So what I do is I write the lowest common denominator underneath a very long fraction bar, right? And then I write my first expression, 3x. And I say, okay, so the 3x has a 3 underneath. Sorry, has a 2 underneath. What do I need number-wise? I need a 3, right? Because it needs to have a 6. So I need to turn this into a 6, and I do that by multiplying by 3. It has an x plus 1 underneath. What does it need?
X minus 1.
Needs an x minus 1. Right? So you want to say, I need to turn this into this. Well, so it's got a 2, so I need to have a 6 and multiply by 3. It has an x plus 1, but I need an x minus, so I need an x minus 1. Minus. Okay, that minus is just the minus that's in between the two terms. I got a 5. What number do I need to multiply by? 2. Got an x minus 1. Do I need anything else? Need an x plus 1. Okay, question number 1. Does that make sense doing it this way? It's going to make your life a lot easier. This makes sense. Yeah? It's like, okay, good. Yeah, I can do this. Because if you look in the book, I mean, what you have to do in the book is you're going to take each term, right, and be like doing, so the book would do it like, if we had 1/2 plus 2/3 plus 3/4, they would go, it's 1/2 times 6 over 6 plus 2/3 plus 4 over, right? You'd be doing a lot of work to get that common denominator, right? This way is a little bit shorter. Okay, you just say we're just going to do the work once. We don't have to take each term separately and get the common denominator. We're just going to go straight to the common denominator. Okay, so now let's look at this and say, all right, what's this? 9x, right? Because it's the 9x that we have to multiply by this and this, right? We got to distribute 9x through here. What's this? 10. Okay, so let's do the next line. Start off with the denominator, right? Because the denominator, nothing's changed. Okay, up top, what do we got? Well, we got 9x times x. What's that? 9x squared. We got 9x times minus 1. What's that? Minus 9x. We've got negative 10 times x. What's that? Minus 10x. We've got negative 10 times 1. What's that? Okay. So we got 9x squared minus 9x minus 10x minus 10, which will be, I should write down the answer. I never even wrote down the answer. So 9x squared minus 19x minus 10 and remember the restriction, right? Because it tends to disappear off the top of the page. Or for you guys, it's like 6 lines further up the page or something, and you know, it tends to be out of sight, out of mind, right? But it's still there. Now, here's the question. It's like, should I do anything with the 9x squared minus 19x minus 10? Here's the answer. If this is going to factor such that one of the factors will be one of these guys, a 6, an x plus, then I would try and factor it. I don't believe that's going to happen here. Right? I don't think I'm going to get a factor of x plus 1 or x minus 1. Right? Not going to happen. So then I'm not going to bother. Right? And in this case, it's a bit of an ugly number, but you know, it's either a 3x and a 3x and a 5 and a 10 and a, right? I mean, how do you get a 10? The only way you're getting an x plus 1 or minus 1 is if one of the factors of this is x plus 1 or x minus 1. If it is, the other factor is going to be an x plus 10 or an x minus 10, and there's no way with a 9 or a 3 and a 3 that I'm going to get a 19. So it's just not going to happen. It might factor, I don't know. I don't even care. I'm just saying, if it does factor, it ain't going to factor to be 6x plus 1, x minus 1. How could you know that? If you're doing a test, you could just graph this and just look to see, is it going through 1 or negative 1, right? Which would tell you that there's a factor of x plus 1 or x minus 1. Okay? Oh, any questions on that? I'd go back. Yeah.
Do we have to factor the bottom then?
Isn't it already?
But, or like, not factor, but like expand it out to see.
No, never expand the bottom or the denominator. Okay? Never expand the denominator, right? Unless for some reason you are told to. Or if you see a multiple choice answer and you can see the denominator is not in a factored form. So in general, we will leave the denominator in a factored form, and most of the time we will leave the numerator unfactored unless we can recognize that, hey, this will factor and one of them will be this, and I can cancel it further down, right? That I can further reduce. Okay. 2 more examples. Yeah, see? Nice short day. Okay. Did I say short day? Yeah, there might actually be a little bit of work involved here. Okay, there's nothing here you can't do, right? I mean, everything that we're doing, you've done. It's factoring, it's stating restrictions, it's then going through and expanding, right? But they're all skills that you have, right? We're just putting them all together in one question. So what's the first step? So we got to factor the denominators. Numerators don't need to be factored, right? As a matter of fact, you should not factor them. I mean, in this case, they don't anyways. But if a numerator had, the only reason I would factor a numerator is, and this is a possibility, it's possible that if this factored, it may actually cancel a factor top and bottom. So in that case, I would look at saying, hey, if I factor this, can I get a factor? Because if I cancel them, which is allowed, right? Just remember that it's a restriction. Then it's just going to be a much simpler problem to solve. Okay, but so 2x minus 1, that stays in this. And 2x plus 1. You know what I'm going to do with these guys? I'm just going to throw them in parentheses because they're going to have to be in a moment. Okay, so then you have to factor these guys, right? After you factor, what do? Check. Thank you. Good. So factor and then, because if you get the factors wrong, you know what happens from this point? You're going to spend 10 minutes getting no further marks, right? At that point, if it's wrong, the question becomes a lot more difficult than it would have been, and everything you do is wrong. So, okay, I need a minus. No, I need a plus. So, where are we going to go? 1 and 1. Yeah, well, that was kind of easy. And same deal, right? Okay, but very important, right? Anytime you factor something as a 2 binomials, check it. Okay, what's next? Restrictions, what are they? Okay? Don't overstate them. In other words, don't give me restrictions that aren't restrictions. Okay? So it's negative a half. That's the restriction here. Negative 1. Negative 1/3. Negative 1. Don't repeat restrictions. The restriction is negative 1, and then there's another restriction of negative 1. I don't want to see it twice. I won't necessarily mark that as wrong. But if you go and you throw in, oh, it can't be positive a half. That's wrong. Okay, and usually we only give a half mark for restriction, so any mistake is just going to wipe out that half mark. Surely. Yeah. What's the LCD? What do I need? I need a 2x plus 1. Okay, what else do I need? I need an x plus 1. What else do I need? What else do I need? No, I already got one. Yeah. So all you do is just start listing everything that's different. Right? So, okay, I need a 2x plus 1. I need an x plus 1. I need a 3x plus 1. No, I don't need another one of these. I already have one. Right? Now, if this had been like x plus 1 squared, then I would need an x plus 1, and I would need another x plus 1, right? Like I would need them both. Okay. All right, so let's put down the common denominator. 2x plus 1, and let's, reorder it a little bit. Okay, so I want you to try and figure out what goes in the numerator. Okay. Don't expand it yet, just write down, okay, so then this is what I'm going to need in my numerator. Because if you can do this, then after 10 or 20 practice exercises, you'll have it down. Right, so we're just looking at the pattern. What did we do? Wrote down this.
It's supposed to be ridiculous and long.
No.
It's only 4.
What do we need here?
3x plus 1.
We need 3x plus 1. Do we need anything else? What do we need here?
2x.
We need 2x plus 1. That's it. So that's what you wrote. Woohoo, right? Good stuff. Okay. Now go expand it.
Why do you need a 2x plus 1 on that side?
Because you don't have one underneath the right-hand side. If you look at the right-hand expression, what's in the denominator? Right? What's here? Got one of these, got one of these. What am I missing? One of these. Okay, I got to put one of these up here. So the idea is, you look here, you got 2x minus 1, right? Now you're looking here and you say, okay, got it, need it, right? It's like doing your trading. You ever trade cards as a kid, or as a younger kid? You ever trade cards when you were a younger kid? It's like hockey cards. Got it, need it. All right, that ages me. We used to do that. They were cheaper then. We bought them for the bubble gum. But you'd sit there, right? You got trading cards, right? And you say, well, you got that one, I got that. I need that one, right? So you look, same deal here, right? 2x plus 1, okay. So you're looking down here, and you look here, you say, got it, need it, got it. Okay, so I need it. I got to put it up there. You look down at this, you look at this one here, you get 2x plus 1. It's like, got it, need it.
To even it out.
To even it out, yeah. Well, it's to make it so that this expression has the common denominator, right? This needs a 2x plus 1 down here. Well, to do that, it's going to have a 2x plus 1 up there as well. Okay, expand the top. Bottom stays the same, right? Denominator. Okay, and just use your... You do this in as many steps as you want. So some people, if you're foiling it out, you need to show all 4 terms, and that's fine, right? And if you're not, if you can do it as writing out the 3 terms, that's fine. And eventually we got to collect it down, right? So whether this goes 4 terms here and 4 terms here, and then we collect them, or you do it 3 terms, I'll do the 4 terms. I mean, why not? So we get 6x squared plus 2x minus 3x minus 1 plus 4x squared plus 2x plus 2x plus 1. Now the nice thing here, the thing that kind of saves you here is, this is a plus sign, so I don't have to do anything special here. If this were a minus sign, I would put the minus here and put a set of brackets and expand that out within the brackets, right? Because the minus sign here would have to be distributed through all of these terms. Okay, so you really got to watch when there's a minus sign. Okay, plus sign, not so much. Okay, and what you might want to do is, in this case, let's just do this. So I'm putting brackets around. This is my first expansion, right? I'm going to keep it in a set of brackets. And then I'm adding, and this is my second expansion. Okay, if we do that all the time, then here it's like no big deal, right? You're collecting terms. I don't have to do anything special. That's a plus. But if that's a minus sign, then I realize, oh, I got to change that, change that, change that, change that. Okay. Denominator stays the same. That needs a parenthesis there. And now we collect terms, right? So I got 10x squared. Okay, let's check them off as I do this. Plus 2. So minus 1, plus 1, plus 3, and 0. And we're done. Good.
Shouldn't you take out an x from the numerator?
Does it cancel? No, so why bother? So this can be factored as x bracket 10x plus 3. The x doesn't cancel with anything down here. The 10x plus 3 doesn't cancel with anything down there. Maybe in the book you see it as x bracket 10x plus 3. Not really sure what they, I don't know if they're consistent in their answers when they do that. I'm okay with this, it's fine. Right? If there were an x down here and you left that, then I'm not okay. It's like, no, you could have factored it out and canceled. But in this case, you're pretty much done. Okay. Good. Questions on this? So you got the idea, right? So the idea is we're just saying, right? Let's look at the thing. The idea is, all right, I'm going to take whatever denominator I've got to factor it. I need the factored form, right? Otherwise, your common denominator becomes this times this. You end up multiplying this by this and this by this. You have cubes, you have squares, you have a big mess, right? Like, seriously, it's just, at this point, it's totally wrong. I'm just going to put an X through and just say no, right? Like, you missed
Get
out.
the right answers.
If you multiply this by this and this by this and eventually end up with the right answer, I'll give you the mark. And I'll just say, and that's why you ran out of time, right? Because you will run out of time. So here's a hint. If you're looking at a horrendously complex expression, or you're looking at, okay, so this is what would happen, right? And I mean, in a sense, there's nothing wrong with this.
We have 2 days of this.
Okay, so what I've written, there's nothing wrong with that. It's just going to lead to a whole lot of pain and not much in the way of marks, right? Because when you go to expand the left side, you now have 6 terms, right? You're multiplying 2 terms by 3 terms. And then you have another 6 terms. And you're going to have cubes and squares. And the cubes aren't exactly going to cancel each other out, right? It's not like, oh, I'll get a 6x cubed, and then I'll get a minus 6x cubed. No, I'll get a 6x cubed plus 4x cubed. I'm going to have a 10x cubed. You don't know how to factor a cubic, right? If you do that stuff, if you did that and you could do that correctly, stuff would factor out. It's just 20 minutes later, you're going to have a big mess and nothing is going to factor out. Right? And I'm not going to give you any marks for it. Right? I'm going to look at it and just go, nope. Right? Unless sitting down at the bottom is the correct answer. And, it won't be. Okay. This just basically says you don't know what you're doing. Right? And you're about to waste 20 minutes doing it. Okay. So here's the deal, right? What do? We have to factor this and factor this. We then state our restrictions. We then figure out what's my lowest common denominator, right? So need this, need this, need this. Already got one of those. Don't need another one. And so on. Okay, last one. Easy, huh? Not done yet. There we go.
Wait, what?
Yeah. Wait, what? So this is called a complex fraction, right? Because it's a fraction over a fraction. Okay, so here's the question. If all I gave you was the top, could you do that?
Yeah.
Okay, so fine. Let's do that. Oh, well, wait. Okay, before we do that, are all the denominators in factored form?
No.
No. Okay, so. So let's rewrite this, right, because that's factored. So there's nothing special to do up here. What's x squared minus 9?
X plus 3 times x minus 3.
Yeah, x plus 3, x minus 3. So what can't x be? Negative 3? Or 3. So let's say plus or minus 3.
Wouldn't the very bottom just be multiplied?
Wait, what?
Like the very bottom terms,
Yeah.
just being divided twice, wouldn't that just be multiplied? Isn't that how that works?
I'm not sure. All done? Oh, okay, yeah, no worries. Okay, here's the deal. Could you do the top fraction, right? So we've got a fraction over a fraction. Top fraction is 1 over x plus 3 plus 1 over x minus 3. Can you do that? Okay, yeah? Do it. So let's go down here, right? Say equals. Okay, top fraction. What's the common denominator for the top fraction?
X plus 3, x minus 3.
This guy here, right? Yeah, x plus 3, x minus 3. Okay, there's a 1 up here. What does it need to be multiplied by? Okay, so all we're just doing this. So what's the 1 need? X minus 3. And what's the plus 1? Needs x plus 3. So that's top fraction, right? Like that's the next step in the top fraction, yeah? Everybody agree? Okay, that's all we're doing. All right, and then it's over. If I just asked you to do this bottom fraction, could you do it? Yeah, okay. So what's the lowest common denominator? X plus 3, x minus 3. Okay, the first term here, there's a 1. What does that 1 need?
Nothing.
Where?
Yeah, isn't that
Oh,
zero?
sorry. Yeah, x. You're right. Okay, what does that x need? Nothing. Right? Like it's already over what it needs to be. So if we want, we could throw 1 in there, just say, yeah, you don't really need anything. Plus, and what does that 1 need? It needs an x minus 3. All right, so, we're ramping up because I gave you a complex fraction, but a complex fraction is just two rational expressions, which we know how to do, and these aren't even particularly difficult ones, right? Like we didn't even have to do much up top. There was no factoring to do. So let's just keep working the top. So what's the top become? Well, so here, we've got the x plus 3, x minus 3, and I want to simplify this, right? So what do we get? You can just do it. It's just going to be 2x, right? Okay, and it happens to be over something. Okay, now what's that got? Well, we know it's got a denominator, x plus 3, x minus 3. And what's it got? 2x minus 3. So now we have one other restriction, right? Because if this is 0, then what's this? 0. And then I would be dividing by 0, so then 2x minus 3 can't be 0, so x can't be 3 halves, right? If x were 3 halves, then this expression would become 0, which would make the denominator 0, which would make the whole thing undefined. All right. What do you do when you divide fractions? So what's the key? Dividing by fractions, what do you say? I want to divide by a fraction, so I do kiss and flip. Okay, so here's what we're going to do. We're going to take the top fraction, 2x over x plus 3, x minus 3, and we're going to multiply it by, and we're going to flip this, right? So it becomes x plus 3, x minus 3 over 2x minus 3, and we're going to say, so that's equal to what?
Couldn't it just be negative 3 then? Or 1 over negative 3?
You do that, I'm taking a full mark off. You can't do that.
If I would factor.
Yeah, hang on. Pause.
Okay.
Yeah, I gotta make this smaller. Wait, how do I make this smaller? View, not full screen. Ah,
Just drag it aside.
yeah, I can't. And so, as was said by a wise man about attempting to do that. You can't do that! Oh, see, now that video just goes horribly bad. Okay. Yeah. So, as he said, you can't do that! You can't do that. Okay. You can't do that, right? I don't know what the penalty was. It was like tripping or something, but that was in an actual game where, he said, you can't do that. So, yeah, you can't do that, right? And the reason you can't, so if you think you can do that, then try it with a value, right? Just say, well, so I think it's negative 1/3. So if x is 1, I get 2 over negative 3. Okay, that's not negative 1/3. If x is 0, I get 0 over negative 3. That's not negative 1/3. Right? And if you are going to try something where you want to do a simplification like that, and you're not really sure, substitute in 2 or 3 values, right? If it works for 2 or 3 values, then maybe you can do that. But if it works for 1 value, maybe you just pick the 1 value for which that's true. So try a few values.
Did you cancel the 2s though?
Nope.
Just don't.
In answer to the question, could you cancel the 2s?
My God.
Can't do that! Right? Whether it's the 2s or the, yeah. No. Okay, so the only thing you cancel is common factors, right? And there is a 2, so the factor, there's a 2 and there's an x. Factor of 2, factor of x, there's no factor. The factor is 2x minus 3, right? It's the whole expression. And again, so if you think, hey, can I cancel the 2's and just end up with like x over x minus 3? Oops. You say, okay, can I get x over x minus 3? You say, well, so if x is 0, I'll get 0 over negative 3, which is 0, and I'll get 0 over negative 3, which is 0. Right? But don't just do 1, right? Then try, okay, well, what if it's 1? Then I get 2 over negative 1, which is negative 2, and I get 1 over negative 2, which is negative 1/2. So, yeah, okay, I can't do that. Okay, so they have to be factors, right? It's got to be something like, so if I had, okay, then I would say, okay, so that's, either I would say they're all divisible by 2, and so I can do this, right? Or I would say, let's leave the 4 there and write this as 2 bracket 2x minus 3, and then I can cancel those because they're factors. Okay, but none of that actually happened. There were no 4's, right? The answer is just, so here's what happened, right? The x plus 3 is canceled, the x minus 3 is canceled, And that's what I'm left with, right? And if you didn't have the 3/2 as a restriction yet, then you should now go and say, oh yeah, because in a complex fraction, you can't look everywhere for restrictions, right? Like you can't do them all at once from the factored form. And it's not like you're going to get a million complex fractions, right? I mean, if you had one on the test, that would be more than enough, right? But you will see a few in the book, so it's just worth practicing them, right? I mean, and what are they really, right? It's just, well, all I'm doing is, all I'm doing is working out a rational, adding rationals, and all I'm doing here is adding rationals. And I'm just, it's like doing two questions, but they're kind of stuck together with a fraction bar in between them. Okay, till we take it down to the bottom and it all cancels down. So, oh, hey, look. So, here's the thing. It's like, really? Like that whole big expression there is, I would get the same, I put in a value of x of 10, so I get like 1/13 plus 1/7 over 10 91st plus 1/13, and that's all just going to work out to 20 over 17. Right? And the answer is yeah, it is. Right? Because it's going to work for every value except for these guys. Okay.